All right, welcome everyone. So if you're using PC Guard's remote protection, you really need to get a handle on machine locking. It is the absolute core feature that prevents license sharing. In this explainer, we're going to walk through exactly how to configure your policies to create a system that's both secure and user-friendly. Let's dive right in. So here's the game plan. First, we'll cover the basics, what machine locking actually is. Then, we'll dig into the specific hardware and software fingerprints you can use. After that, we're going to get practical and show you how to build a locking policy, explore some really powerful advanced options, and finally, we'll cover how updating your policy affects your existing users. Okay, let's kick things off with the big idea here. Machine locking isn't just some optional feature. It's the very foundation of your security. It's the mechanism that binds a single license to a single computer. This is your first and, honestly, your best defense against casual piracy and the key to making sure your licensing model is enforced. So how does it actually work? Well, the policy you set up grabs a unique mix of identifiers from the user's system. It then uses these to generate two super important codes, the site code and the machine ID, or MID. You can think of these together as a unique fingerprint for that specific installation. And these two codes? They are absolutely fundamental to how the whole activation process works. All right, so now let's get into the nitty-gritty. What are the actual building blocks we can use to create that machine fingerprint? These are the specific software and hardware identifiers, or what we call locks, that PC Guard can read from a user's machine. These parameters basically fall into two camps. On one hand, you have software locks, like the hard drive ID and OS ID. Now, these are tied to the operating system installation itself, which means, yeah, they can change if a user decides to reinstall Windows. On the other hand, you have hardware locks. These are tied to the physical components. We're talking the CPU, the motherboard's BIOS, the network card, which makes them way more persistent. And here they are, all laid out for you, the 7 locks you have at your disposal. 2 are software-based, and 5 are hardware-based. As you can see, each one targets a very specific attribute, from something like the system drive's volume serial number all the way to the manufacturing date of the motherboard's BIOS. This gives you a really powerful and flexible toolkit to define what makes a machine unique for your specific application. Let's just zoom in on the net ID for a second, because its logic is pretty sophisticated. First off, the protection code is smart enough to completely ignore virtual adapters from software like VMware or VirtualBox. It knows to prioritize the more stable internal network cards over, say, an external USB one. And here's the really crucial part. After activation, it scans all the adapters every single time the app runs. This means even if the adapter order changes in Windows for some reason, the lock stays valid as long as that original card is present and enabled. Okay, so we've got our building blocks. Now it's time to put on our architect hat and actually craft a policy. This is where we define the rules for how strictly the application is going to enforce these locks when it validates a license. So let me ask you this. What happens when a specific piece of hardware is just absolutely essential for your application to run? Maybe your software requires a network connection, and you want to be 100% sure a network card is always present. What do you do then? Well, this is exactly where mandatory locks come into play. When you mark a lock as mandatory, you're basically telling PC Guard that its presence is non-negotiable. If the protection code can't find that component, like, say, a network card for a mandatory net ID lock, the application won't even show the activation dialog. The app just won't run. End of story. And to make your life and your users' lives a whole lot easier when troubleshooting, if a mandatory lock is missing, a specific error code pops up. This is a lifesaver for your support team. If a user calls in and says they're seeing error code 4, you immediately know the problem is a missing network adapter, which means you can give them precise instructions to fix it. Now let's talk about user experience for a minute. By default, the policy is really strict. If any single selected lock changes, the license is invalidated. But think about it. What if a user just upgrades their old DVD drive to a Blu-ray player? Forcing them to reactivate for something so minor can be pretty frustrating, and that's where flexible locking comes in, offering a much more forgiving, user-friendly approach for these small hardware changes. Setting this up is pretty straightforward. You just check the flexible locking option, mark which specific hardware locks you're okay with changing, and then you set a threshold. So, for example, you could say you'll allow up to 1 change among 4 different hardware locks. And here's a really important thing to remember. This check isn't cumulative. On every single launch, it just compares the current hardware fingerprint to the original one from activation and counts how many things are different right now. Okay, now we're going to get into some of the really cool stuff, the advanced options. These settings give you incredibly granular control to fine-tune the behavior of your protection policy, especially for specific scenarios and edge cases. This first one is super important to understand. By default, if a lock changes, boom, the license is immediately reset, an error pops up, and the application closes. But if you disable this option, the whole game changes. The old license doesn't get wiped. Instead, the user is just prompted with the activation dialog and some new codes. If they can't activate, they can just close the dialog, and if that hardware change was only temporary, the app will work again on the next run without needing a new key at all. All right, next up is an option that's all about user convenience, and this is a big but, it comes with a major security trade-off. By default, site and MID codes are randomized for extra security. If you turn this off, especially if you also disable the software locks, it means a user can reinstall their entire operating system on the same machine and get the exact same site and MID codes. The convenience is obvious, but you really need to be aware of this. It can allow a user to reactivate with an old key, even after you've already processed a license removal for them. And for those of you worried about more advanced users trying to game the system, this next option is for you. It really hardens your NetID lock. What it does is it specifically counters any attempts to spoof a MAC address. When this is enabled, the protection code will actively try to determine the original factory set MAC address of a network card. If it detects a MAC address that's been manually changed and it can't find the original, it will simply refuse to use that adapter for locking, completely thwarting the attempt. Finally, let's talk about something really practical that you're definitely going to run into. You've released your application out in the wild, and now you want to push an update with a new, maybe stronger machine locking policy. What happens to all of your already activated users? Well, the outcome really depends on the user's situation. Scenario 1, if a user hadn't activated yet, no big deal, the new version just generates new codes for them. Now, what if your update only removes locks, making the policy a bit more lenient? Good news, existing licenses stay valid. But here's the big one to watch out for. If you add new locks and make your policy stricter, the user's license will be reset, and they're going to have to reactivate, so you'll want to plan for that. So, to wrap this all up, what are the main things you need to remember? It really all comes down to finding that sweet spot between security and user convenience. You want to start with a good mix of software and hardware locks, but be really careful with mandatory locks. Only use those for components you know for a fact will be on your user systems. And definitely leverage flexible locking to create a more forgiving experience that will save you from unnecessary support calls. And don't forget, the Machine ID decoding feature in the activation panel is your best friend for troubleshooting any of these issues. And that really leaves us with the big question, the central challenge for you to think about as you configure your next project. How can you design that perfect locking policy, one that's robust enough to stop piracy in its tracks, but flexible enough that it never, ever gets in the way of your legitimate, paying customers? That's the real goal, and now you have the tools to achieve it.